Right, so we were asked to identify what is the equation of the velocity if we have this acceleration function, which is the quantity of x cubed plus 2 squared multiplied by 3x squared. Alright, so we were asked to get the equation of the velocity if this is our given acceleration, and then we need to get the exact measure of velocity after 3 seconds. So basically an object is moving according to this acceleration function, and we need to find the velocity after 3 seconds. So that is our objective. So now we're talking about physics. So as we all know, velocity is basically the total accumulated change of acceleration. Or in other words, acceleration is the derivative of velocity over time. But oh wait, no. Acceleration is the derivative of velocity. That's it. So basically when we say that acceleration is the derivative of velocity, it talks about that it defines acceleration as what is the rate of change of velocity over time. So basically, in much more simpler words, if you don't understand, basically how much velocity is, how fast velocity is changing over time. So as we all know, velocity is changing, right? Because of course our speed is increasing. That is because of acceleration. We're accelerating. That speed, that velocity is increasing. So acceleration is what we define as how fast that velocity is changing, and it's also the reason why our speed is increasing. So yeah, if that is the case, if acceleration is the derivative of velocity, then velocity is the antiderivative of acceleration. So we're going to integrate this acceleration function. So we can go ahead and do this equation, which is the integral of the quantity of x cubed plus 2 squared multiplied by 3x squared dx. And in order to solve this integral, we need to use du substitution. So let's say I want to define this as u. Alright? And I want to define the du. So when we say du, basically we're differentiating what's inside the u. So it means we need to take the derivative of what's inside this quantity. So the derivative of x cubed plus 2 is simply 3x squared plus 2 dx. Yes, we need to include dx because this will be important. Because look at here, these are the same. Oh, oopsies, I made a mistake. The derivative of a constant is 0, so this is gone. I made a mistake on that part. Okay, there we go. These are the same. Alright? So this is our du. This entire thing is du. So that means we can go ahead and divide both sides by 3. Du all over 3, or in other words 1 all over 3 multiplied by du. This is basically serves like a factor, like a neutralizing factor. That's very important when it comes to using u substitution. It'll be you will see why. So we can go ahead and define our new integral as u squared because of course this entire quantity as u, and then we got the squared here, so we have u squared, and then we have 1 all over 3 multiplied by du. Wait, no, oops, that's du, right? Well, we can go ahead and put 1 all over 3 out of the equation. So we can go ahead and say this is 1 all over 3, the integral of u squared du. So we can go ahead and apply our power rule for the antiderivatives. So this is simply 1 all over 3 multiplied by u cubed all over 3, and then plus cheese. So if that is the case, so if that is the case, uh, 1 all over 3 multiplied by u cubed all over 3, it's still the same as u cubed all over 3. So if that is the case, then we can go ahead and do this one. All right, so remember, our u is equals to x cubed all over 2 plus 2, I meant, and that never changed. So let's go ahead and substitute it. So therefore our velocity is defined by this as x cubed plus 2 cubed all over 3, and then plus cheese. But we can go ahead and ignore the plus cheese, because when we take the derivative of this, even with the constant, the plus constant, well, of course the derivative of a constant is equals to 0. So plus cheese wouldn't matter that much. So yeah, so this is our velocity function. All right, right now you don't see the letter t in it, but we can go ahead and replace it according to time. So this becomes t cubed plus 2 cubed all over 3. Alright, so now we have a much more clear picture. Now we know the clear picture of what we're dealing with. So it says here we need to evaluate this at t is equals to 3. So after 3 seconds, we need to find out its velocity. So let's find out what is its velocity. Alright, okay, that's great. Okay, so if that is the case, v of 3 is equals to 3 cubed plus 2 cubed all over 3. So as we all know, 3 cubed is 27. So, and then plus 2, that is 29. Okay, so 29 cubed. Oh boy. So we have 29 times 29. So we have 81. So we have 918. So we have 26. And we have 18 as well again. And then 2 times 2 is 4, so we have 5. So we have oh gosh, 5 plus 2, 7. I'm not gonna count that, okay? Okay, I know the memes. I know the memes, guys. I know the memes. Okay, what's 6 plus 8? 9, 10, 11, 12, 13, 14. Okay, 14. Wait, if that is the case, so we have 1 and 14, and then 3, Okay, 8. So we have 841. And then times that by 29. Times that by 29. And I'm not going to make the video any more longer because I have low storage. So that's 2,000. So that's 24,389. So if I am correct, if I am not wrong, 3 squared plus 2. I meant 3 cubed. Alright. So we have 300. We have 2,400 and 389. All over 3. All over 3. And according here, this is our answer. Meters per second, by the way. The units for this is meters per second. And in order to express this as a fraction, to express this as a decimal, since that's how we're supposed to calculate it in physics. So we have, holy fuck. So we have 8,130, approximately 8,130 meters per second. That is fast. I'm sorry, but that's fast. That's fast. That's very fast. So yeah, that's pretty much it.